Dear senior fees, wherever you are, a good day to all of you who are watching. I'm glad again to talk to you over a long period of time when we are not discussing. It has been very long since we last met. Before we went in for COVID holiday, but as you know, we have been pushing on so slowly, but now we are here to continue from where we stopped when we are there at school. Within our last discussions, remember we had moved a step and we are discussing about a number of things. And today, I want us to continue with that topic which we left at school when we are discussing about, and that topic was data communication and networks. What is data communication? What is the network? We had learned a lot about what is data communication. And we said that it's all about the process of transferring data from one device to another. That's what we said. Within that time, I know the other friend of mine, my colleague, told you that data communication is made up. We have what we call the data communication model, all the elements of data communication. And that way we say that those are the components that have to be available for us to see devices communicating to one another. That time I remember we say that we have what we call the sending device, receiving device, communication device. Then we also have what we call communication protocols, software. So those components you discuss about, unless one of them is available, we cannot see communication taking place amongst what you call devices. Now, my major interest today, I want us to start from what we call a network. I know by the time we left, we had talked about a network. But let us have a simple preview over what we call a network. What is a network? So we are going to go through it very fast so that we reach to the other point which we did not talk about. So we are now on what is a network. We are saying a network is all about a system of interconnected computing devices connected using what we call transmission media. Remember the media we said is all about that material that is used in the process of exchanging data from one device to another. So that one is called a network or a computer network, a system of interconnected computing devices. A system of computer A, B, C, or computer A and B connected to one another, communicating to one another. When the two were able to communicate to one another, we say there is what we call a network. Okay, so that's what we said. So you pick your phone and you're able to call a friend, and that friend is able to respond as the two phones are communicating to one another. There is what we call a network. So that's why we say just a system of interconnected computing devices connected using what we call transmission media. The process we go through to make devices to communicate to one another, the process we go through to configure, to set computer A to talk to computer B, that process is called networking. That's why I'm saying networking is the practice of creating, maintaining, securing, and troubleshooting a network. The process we go through to set up a network is called networking. The process you go through to make a computer A to communicate to computer B, computer C, and computer D is referred to as networking. We discuss about nature or forms of networks. Remember when we were at school. I'm repeating these things because you have taken some good time without going through them. That's why I'm going through them very fast. We say that networks are classified Yes. And the classification of networks, they are based on a number of factors. Or few of them. One, the network coverage in terms of distance. The network can cover which kind of what? Distance. Will it be able to cover only 2 meters, 1 meter, or on what you call a global level? Then number of people or devices the network interconnects. How many individuals can that network support at a what? At a time. Then also the nature of technology being used to connect that network. So those 3 factors, we use them in the process of determining the types of networks we have. Therefore, my friends, we say that we broadly have 3 types of networks. We broadly have 3 types of networks. That's what we said. We said that we have what you call the local area network. We have what you call the metropolitan area network, and also what you call the wide area network. So we mainly have 3 major types of networks. However, we shall come across some other networks as we talked about them in class. There are some other networks that are available, and those networks fall under the other first 3 types of networks. I think you can recall what we said. So in that way, you have what you call the local area network. Remember, we talked about it. You have the metropolitan area network and wide area network. Now, I've managed to list for you some other like the personal area network. That network that is around the individual. I'm using this computer. There are some devices that are connected on this computer. For example, I have a printer here. I've formed a certain network around me. It is a personal area network. We have a home area network. There at home where you are seated now. You can make your computer or your phone to communicate to another phone around, or a printer around, or at home there. So when that communication is established there at home, amongst devices, you have formed what you call a home area network. We have the wireless local area network. Wireless area network. It is a local area network, but in a wireless format. Now, since we are going through very fast, we discuss about them, we are revising. We have what we call the first type called the LAN. Yes. A network that interconnects computers in what you call a smaller geographical area. This is the type of network that connects devices in a small geographical area, such as a building, a computer laboratory, an office, like that. So that one is called a local area network. When we are defining local area networks, it is very important to talk about the approximate distance. Yeah. It's very important to talk about the approximate distance they do what? They cover. Because if you just say small geographical area, somebody may ask himself which kind of that area you are talking about. So it's very important to specify the area. So in our definition, we should always come up with simple examples of the limited geographical area we are talking about. Then we are saying that the nodes are connected to the LAN via what we call cables, or in the case you have a connection that's in the form of cables, it's a physical connection. Yeah? So we can have a LAN that is connected through use of cables. Okay? And you can also have LAN, which is established in a wireless format. So when it is wireless, we say it is wireless local area network. In that way, you have devices that are connected to one another within what we call a limited geographical area, but in a wireless setup. Yes. So that one is called wireless local area network. My friends, wherever you are, we say that wireless local area network is also categorized into 2, or the way we set devices in what we call local area network can be formulated in 2 ways, either in what you call peer-to-peer or client-server. a peer-to-peer or client what? Server. These ones are called kinds of LAN, and they are available according to the way you connect those devices. Yes, you can connect them in a peer-to-peer. And peer-to-peer is all about connecting devices when all of them they have equal responsibilities. They have equal powers to manage themselves. I have 3 computers. Computer A, B, and C. Every computer has full powers on that network. It is a peer-to-peer. And in a client to server, we said there is 1 or 2 machines or 3 that are made to control others. So those ones that are in charge of controlling others, we said they are referred to as servers. And those ones that are controlled are called clients. Yes. As we are going through, we will find that when you look at the screen there, you can see that simple setup. Yes, I have a LAN setup around their computers. These are servers and some other clients here. There is a printer just within a limited geographical area, very small. So let us talk about this peer-to-peer, which you have said that features of peer-to-peer. Remember, members, we are briefly reviewing those kinds of local area network now. And the first one is called peer-to-peer. We say that with peer-to-peer, there is no device that is responsible or computer that is assigned responsibility of managing others on the network. Every computer on that network has what you call full powers to manage itself. Therefore, files on computer A can be accessed by computer B and so on. But computer A can store its own files and computer B is capable of storing its own what? Files. Computer A has its own softwares and whereas computer B has its own what? Software. But computer A can get resources from computer B. Likewise, computer B can use very well resources on computer A. So, a network where all computers on networks are called what? Peers. All computers on networks have full responsibility to manage others, to manage themselves when they are on the network. We are saying this kind of setup is ideal for computers that are not more than 10. When you are connecting devices, they should not exceed 10. When they are more than 10, it may not be very effective. Yes. You see that setup on the screen very well. Remember what we said? You can see those computers, A, B, so they are connected. Yes, but computer A has full powers like computer C. Likewise, this one has full powers like that one. But they are connected, they are communicating to one another. Then let us briefly go through those advantages of peer-to-peer, the way we talked about them there in the class. We say that a peer-to-peer network is simple to set up. You have seen here. It's a matter of getting cables. You get a switch or a hub here. Then you lay cables from here to the switch. Then you make very simple setups or configurations on those machines. At the end of the day, you will see that things are working out. Devices are communicating to one another. Then, it's not a dedicated server. There is no special machine that is reserved in the place of controlling others that is called a server. It's not there. Then we are saying it is perfect for home and small what? Business users. They at home, you can, if you want to set up your computer, a printer, and very few devices communicating to one another. It's too stable for that setup. Very small. Because it is designed to cover a very limited geographical area. My friends, we talked about the disadvantages of peer-to-peer, you remember? Yes, it's not very secure as users connect freely without any substantial system what? Restrictions. Yes, it is not very what? Secure. Why? Since every system has full powers and is capable of connecting without any restriction. If you have files on computer B that you don't want computer A to know about, yet he has full powers to use all things on computer B, you find that it is not secure. So if we are in a place where there is a lot of, or that requires a lot of security, you find that things may not work out. Then its efficiency and effectiveness keeps on reducing as more computers or as more computer devices are connected. The more we connect more devices on network, it will turn out not to be very effective. That's why we said it is very effective when you don't exceed 10 devices. Yes, then it is limited to a very small organizations and homes. That one we have seen. The total bandwidth increases as the number of peers do also increase on the network. Yes. Then when the bandwidth is more on the network, we find that there is congestion or traffic. We may see traffic taking place over the network. Then we say that the system is not centralized, has no centralized administration. So if there is no reserved one to manage them, or what you call centralized administrator, therefore managing things on that network turns out to be very difficult. Since every device has its own control. Okay, my friends, let us talk about the client server briefly also. Remember we said that it's a network with one or few computers assigned with responsibility of managing other computers on network. This kind of network, there is one or two or three computers that are given powers to manage others on the network. Yes. Such computers, they have what you call softwares. Yes. They use in the place of managing others. So they use softwares to manage others. So servers are computers with software designed to manage others that are called clients. I told you those ones that are on that network that are getting commands from the servers, they are called clients. And used to look at that setup, there is this strong machine called a server, and it is in charge of managing these others. These ones are called clients. You remember that in our class. Forms of servers. You remember we talked about the different types of servers. We have web servers. On internet there, per now you are going through these lessons. The lesson you are going through is stored on what you call those servers. The web server. The web server is in charge of managing all internet users requests for web pages. As you are searching, that information is stored on a web server. You have file servers. Those are in charge of managing just files. Yes. An organization can come up with a file server where they store their files that can be accessed within that network. We have application servers. These ones are designed to manage application programs. They are programs that are shared over the network. They are shared over the network. And they are shared by different devices that are connected. Therefore, those devices to use such programs, they always request them from what you call the application servers. Briefly, let us discuss about the functions of the servers. They are in charge of administering client computing on the network, assigning duties and responsibilities that are supposed to be performed by the clients done by the server. Managing security of files and applications. There are some files and applications that are very essential that are managed over the server, so that when you keep on distributing them to every machine, their security is nullified. Then managing printer jobs, in case there is you on the network and you want to use it for printing and you want to use only one printer. That printer is in control of what you call the server. Data backing, carrying out what we call data backups. Yes, creating a reserved storage area for data, so that in case there is a problem to data, there is what we call a reference point. Then managing data uploads and downloads. Upload is transferring files to the server. Download is accessing files from servers. So managing that process of sending your work to the server, then downloading those files from the server. Okay. The advantages of the client-server model, we are saying it is more flexible, as it can accommodate as many computers as possible. Because there is one or two of the machines that are set aside to manage others, therefore you can easily add on compared to the peer-to-peer. It is very secure as the server provides what you call centralized control. Very secure. Yes. Ease of data and software updates. In case we have software as we want to update, remember we said you can easily update. So long as you update the server, it is automatic. All other softwares, all other clients that are using or accessing softwares from that server, they will get what you call an up-to-date software. Then it is ideal for all sorts of what organizations. If it is small, it can accommodate. Large organizations, you can be able to, you can use it. Then you remember we say that the disadvantages, work can be on a standstill when the server is what? In case of a problem to the server, it is automatic. You find that work may come to standstill. Yes. Then it is a bit expensive to set up and what? Maintain. Yes, because of the additional requirements of buying a server, coming up with some other softwares that are used in that process, it makes the work somehow to be hectic. Congestion in network, because it has the right capability of allowing many devices to be connected the way you want, you may face some challenges of congestion. Now, LAN can be wireless. Remember what we also say that a LAN can be connected through a physical means or wireless connection. Yeah. Okay. I'm not going to go through those ones. Let us move on. Now, another type of network, the broad one we talked about is the metropolitan area network, the MAN. This is a network that spans or interconnects computers in a city, town, or urban area. For example, here in Uganda, in Kampala, here may have a network within Kampala. KCA may wish to control Kampala, and they come up with what we need to work within Kampala. That one is called the MAN network that spans or interconnects computers within a city, town, or urban area. Then the last one, the major last type of network is what we call the wide area network. A network that interconnects computers and local area networks across a large geographical area. Whenever we talk about one, just know that the network that spans over a large geographical area. For example, internet. Internet is one of the types of the wide area networks we have. Okay, let us move on, my friends. I'm not going to go through the advantages of networks. Why? We finished that work. The other part, I wanted us to have what you call a review of a network, which we are talking about. Now, today, I want us to continue. We discuss about that part called the topology. 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 What is topology? My friends, where you are in this topic of networks, there is that part called topology. Topology. Topology, whenever you hear about the word topology, topology is all about the way how devices are laid out on that network. the way how devices are laid out on the network. The way we organize our devices on that network. That's what you call, or that's what's referred to as topology. I may wish to connect my computers in form of a line. Yes. For example, here it is a line. Yes. I may wish to connect my computers in a circular way, which is referred to as ring. I may wish to connect my computers with one in the middle and others are connected on it. And this one is called star. I may wish to have such a setup. Are we seeing the mesh topology? And you also have this type of setup, the tree topology, and also have what you call the hybrid topology that combines different types of what you call topologies. So, my dear friends, where you are, we should understand that topology is all about the way how our devices are laid out over the network. So, the term topology is all about the way in which a network is laid out physically. And we are saying two or more devices connect to a link to form what you call a topology. So topology is all about the geometrical representation of the relationship of all links and devices on that network. The way how those devices are linked to one another on that network, that's what we call topology. The physical arrangement of devices on the network. And we have seen very well the different ways in which devices are connected on the network. So, your eyes, what they see according to the setup of the network, that's what is referred to as topology. So, let us move on. We talk about the different types of topologies one by one. The first one is called the bus topology. This one is a network that consists of a single central cable. There is one established node or cable on which all other devices get resources from or they are connected. So we have one cable and that cable is the main on which all other devices are connected to. That's why we are saying this is a network that consists of what we call a single central cable that connects all computers and devices. We are saying that in a bus topology other than, on the other hand, it's a multi-point because of one long cable acts as a backbone. So we are saying in this setup there is a backbone, a long cable, a mainstream, on which devices get resources. You can see that illustration now. There is this cable now. I think one here is a single cable, and we have computers. There is this one, this one, this one. All of them they are dropping to that main cable, the backbone. So in case in that network they are communicating, they are getting resources from this main cable that is established. So when you come across over a network, in that format, we say it is accommodating a bus topology. So it's accommodating a bus what? A bus topology. Next, let us talk about the advantages Advantages of a bus topology. In case you come up with your devices and you lay them out on the network in that format, what are some of the likely advantages you enjoy when you are using that network? One, it is inexpensive and easy to install. The moment you succeed to come up with that backbone, it will turn out to be very simple because all other devices, they will keep on what? Tapping. They will keep on what? Tapping on that main stream or that main backbone that is established. So that what makes the network be very easy to establish. Yes, you don't incur a lot of costs. The matter of so long as you incur those costs of establishing the main backbone, others they will keep on what? Connecting. Then computers and devices can be attached and detached at any point without disturbing the rest of the network. The advantage behind this is that you are capable of removing and adding other devices on the network without disorganizing. We don't disorganize the network. The network will remain working very well. If you want to remove computer A, other computers they remain working. You want to add computer C. As you are adding computers, you are not going to disorganize the network. Yes. So then failure of one device UI does not affect the rest of the bus network. Yes, in case one gets spoiled on that network, we have seen that network members you have seen. In case this one gets a problem, others they remain working because it will be only this cable that is broken. These ones will remain communicating with one another because commands are still flowing through this mainstream. So the communication will still remain. That's why we are saying failure of one device usually does not affect the rest of other devices on that network. Then, members, it requires what you call less cable length or cabling. Yes, you have seen that so long as the mainstream is established, it's a matter of getting one cable from one computer to that mainstream or to that backbone. There we are using internet number what cables. You find that you are going to meet some other topologies that you shall find that they use a good number of what you call a good number of cables when they are established. Okay, let us move on now to another advantage. They are saying a fault or break in a bus cable. We are now on disadvantages, friends. Disadvantages of what you call bus topology. We are saying that a fault or a break in the bus cable stops all transmission. In case there is a problem on that main cable, that network will come to a standstill. Why? The entire access, there is total dependence on that main cable or that backbone. Any problem to the backbone, the network will not be effective. So the network will stop there. What? And that's why you're saying a fault or a break in the bus cable stops all transmissions, even between devices on the same side. Yes. Then you are saying if many computers are attached, the amount of data flowing along the cable increases. In case we connect very many devices, see, there is increase in bandwidth. And where there is more bandwidth, you shall experience corrosion, making the network to be what? To be slow. So collision on the network, we need the network to be very slow. And that one will happen in case you connect very many what? Devices. So make sure that we have limited devices that are connected. In case there are many, we shall experience some challenges. So that is the bus topology, my friends. Remember, we are discussing about the physical arrangement or the way how devices are laid out over the networks. Now let us talk about star topology. We are saying in a star topology, each device has what you call a dedicated point-to-point link only to a central controller. There is one established controller in the middle, and all devices they are able to communicate to one another through that main established central controller. This one can be a hub or a switch and so on. So any device that is thought about to be using that network to be in the middle in managing others. We are saying that in a star topology does not allow what you call direct traffic between devices. Does not allow what you call directly. There is no flow of traffic directly, maybe from computer A to computer B. That has to flow through that central controller, such as a switch or a hub. So the controller acts as an exchange. That's why I'm saying that if one device wants to send data to another, it has to deliver data through that controller. Hmm. So that one is called star topology. You can see the setup here. Yes, there is a hub, or we can use a switch in the middle. Now cables are moving from those computers through that switch or cable. Yes, through that switch or hub. So if this one wants to communicate with that computer, we relay information through that switch. Then information will flow to that side. So that one is called a star topology. You can be there at home, then you come up with what you call a star topology. Let us now go through some of the advantages of a star topology. Yes, we are saying it is less expensive than what you call a mesh topology. Where we are heading, we are going to discuss about mesh topology. And we shall see that there are more cables that are used in mesh topology compared to star topology. So then, the star topology is robust. When they say it is robust, if one link fails, only that link is what affected because we are communicating through the other hub or switch. In case one device gets a problem, that network will not also come to a standstill. Why? The switch is still active. Others they will keep on communicating through that switch. Yes, that's why there I'm saying that all other links remain active. Yeah. And that one makes it easy for us to come to identify a problem. In case of there is any fault on that network, you can easily identify that fault. Why? Others are still active and there is one that is not working, one or two. So long as that switch is still very okay, you usually find where the problem is coming from on that network. Then in good performance, we are saying data packets are sent quickly as they do not have to travel through unnecessary nodes. They only move or go through what you call a switch directly to the intended device. So in that way, we shall see that data tries to move at a very fast rate. Why? Does not go through a number of nodes or a number of other devices that are connected on that network. So it has to go through only one device, that is a switch or a hub. Then it is very easy to install and to maintain. In the moment you have your switch and you have your devices and cables moving from them to the switch, configuring the network to work out is very easy. So that's why you're saying it is very easy to set up. Uh, for today, I want us to end with what we call the disadvantages of star topology. We are saying that if the hub or a switch fails, you find that the entire network will not be able to work. In case the hub or switch fails, the entire network will not work. Then the switch I'm referring to the other central controller. In case it gets a problem, the network will come to a standstill. Then if the central computer fails, the entire network fails. I think that's what we have talked about. We are saying although it requires less cabling than a mesh, each node must be linked to a central hub, and we are saying for this reason, often more cabling is required in one way or the other. Since every device should have a cable that's moving from each to the main or to the what we call a switch or a hub, at the end of the day, in case you are connecting very many devices, you find that you have a number of cables available. So, my friends, with those few, I want us to stop there. When we meet again, inshallah, we shall continue and we discuss about some other topologies. I want to tell you that you stay safe. When you are there at home, avoid unnecessary movements. Concentrate at home and you go through a number of things. We have a number of lessons that are there. You can go through them. Otherwise, I want to say bye bye to all of you.